go.
No one ever uses a hectometer. I wonder why.
Decameter? Yeah.
Well, they use them for hectacres, but
Decimeter?
hectares,
Yeah.
which is about the only use it has. No one uses decameters. Why does nobody use decameters? We should normalize that. How fast are you going? Oh, about 12 decameters per hour. What? What does that mean?
What does that mean?
That's,
Why not just say, like, 1.2 hecameters per hour?
no, because they... see, that's the thing, right? Meters are used all the time for physics class. Kilometers per hour are used for, normal car driving or whatever. Hectacres are used for measuring land when they don't use acres. So, why don't we use
Yeah, that's true. They
a
do.
decameter for something? I vote maybe we should use it for lawnmower speeds.
Well, yeah, that's another arbitrary thing. I don't know where it came from. 43,560 square feet in an acre. Where the hell did that number come from? I have no idea why.
That's a very Googleable answer.
Why are there 43,560 square feet in an acre?
Why is an acre? You know how you spell acre? That's not.
Well,
how
it
you
was probably a standard measurement, and then we just converted it to feet squared. Oh, it is by furlong. See, that's what I told you, 43,560. But I don't know where that number came from. I think it was probably just like, this is how big a land should be. And it just happened to be equivalent to that number.
was defined as the area of one chain by one furlong.
Yeah, which had those units. It's ancient. It's archaic units.
Now we use 1 hectacre, an acre represented as the lower white and yellow checkered region. Acre, hectacre.
And how many hectaacres are in a square or in a section?
I don't know. You have to convert hectacres to square miles. So a hectacre to
Square mile. Square mile. Oh, make this one. No, you did it right. Make that one. That's
Schmuck.
not one. 259.
258.9999.
Yeah, 259.
There you go. I don't know
Why
what
did I need that information?
I don't know. You asked.
Oh,
You're the one that asked in the first place.
yeah, I don't know why I need that information.
Now we know. It was something
We just use sections and acres.
archaic units.
Yeah, it's an archaic definition. That's why the speed of light is so weird. It came from archaic units.
Well, the speed of light's also jank because we measure it off the Earth's year, which is a jank amount of time.
Exactly, that's what I'm saying.
It's all jank.
We define a second off the Earth. We define a meter off the Earth. It's all defined off the Earth.
Which is a jank piece of hardware.
We define a weight by a piece of the Earth.
No, we don't.
Yeah, the platinum iridium, it was... What was it equal to? No, it was 1 kilogram of water or something. That was the original definition. The original definition of the kilogram.
Oh, I don't know what the original definition was.
It's an archaic thing. That was like,
technically, it does work out to be 1 kilogram of water is equal to 1 decimeter.
I think that's what
deciliter.
it was. I think that's what it was. Something like that.
Right? Or is it 1 liter is 1 kilogram?
There's 1,000 kilograms per meter squared.
Yeah, 1 milliliter is 1 gram. So yes, it would have been 1 liter is 1 kilogram.
Anyways, it was something. I think they defined it off of water, and then they just grabbed some hunk of metal and was like, "This right here is the kilogram. This little chunk of metal, a piece of the Earth, is equal to 1 kilogram." That's what I'm saying. It was a piece of the Earth. This piece of Earth is equal to a kilogram. Okay.
And then it started changing mass, and they realized.
Yeah, well, it was within the era of fingerprints. No, it was greater than the era of fingerprints, and it was it radioactive or something, or I don't know what they were using.
Platinum and iridium. I
Well,
don't.
no,
know.
that was the original definition of a meter. The meter was a platinum iridium bar,
Right.
and then they're like, yeah, this is also bad.
Should have gone gold.
So then they decided to use the Planck's constant. They made a watt balance scale.
Now it's based off a silicon sphere, the
No.
smoothest object in the known universe.
No, not any. No, it's based off the watt balance.
Well, yes, but they had to use a silicon sphere to
No,
balance.
that was no. Veritas made a video. Is one proposal, but they decided against it because it's still a solid object.
I thought they were going to use it to balance it, though.
No, they had to define gravity and all that. They had to get a gravitrometer or whatever they call it. No, they did not use the silicon sphere. There were two methods. One was the watt balance. The other was the silicon sphere.
I want that silicon sphere.
They decided against the silicon sphere because basically their method was just to count the number of atoms inside. But it's still a solid object.
That's a stupid idea.
That was their method.
The smoothest object in the known universe.
Yeah.
Isn't that cool? When your civilization can be like...
Because what they say, they said if you were to make that the size of the Earth, the difference between the highest and lowest points on that sphere
Like an inch.
was like 14 meters. No, it's the size of the Earth.
Yeah, that's what I said. It'd be like off. I thought it was even better than that.
No, it's not an inch. It's like 14 meters. It's smaller than the difference, way smaller than the difference between Mount Everest and...
Well, yeah. I thought it was even
And
more
challenging
precise than that.
No, 14 meters is what they said, something like that.
Well, that's not very smooth.
That's the size of the Earth. What do you expect?
I expected better. I expected them to polish that motherfucker.
And if anything, they're not going to use the inch.
Fine.
They're scientists. They're not going to use the inch.
3 centimeters. Christ. Although, truth be told, that might be within the radius of one silicon atom at that point, especially if you blow it up to the size of the Earth.
Exactly.
So it might not work at that point. What would that be?
What?
Well,
So how big is an atom at that scale?
Yeah.
I don't know.
Baseball?
I have no idea.
No, couldn't be that. Well,
I have no idea.
there's a lot of freaking atoms
There is.
in that sphere.
All I know is that
We calculate it.
we could, but the other calculation that I can never get behind is that there's like a million different ways to show the proportions between the nucleus and the atom. I've heard a stadium and a flea inside the stadium. I've heard a stadium and a baseball inside that stadium. I've heard a soccer stadium and the soccer ball inside that stadium. Each one's bigger than the last. How big is the nucleus?
Well, somebody might have picked... that first one, they might have picked...
They picked the world's smallest stadium, and then... Oh, yeah, it's a flea. Then they picked the average MLB stadium.
I was saying
now it's a
they
baseball.
picked the hydrogen atom, and then the last one, they picked a cesium atom.
Yeah, something like that, I guess. But I'm just saying, it's like each proportion is different than the last.
Well, we just calculate it.
Yeah, you could. But see, the problem is it's a sphere of possibility. It's not like this is where the electron is. It's where you're most likely to find an electron. No, you're most likely to find it within that entire sphere, not at the edge.
What a fun probability curve. It's a probability sphere.
Sphere, yes.
That's like it was like Barney when he's coming up with the chain of screaming.
It's a three-dimensional...
And he was like, fine, the pyramid of screaming. That's what this is. Fine, if we don't want to use whatever unit we were going to use this.
It's a three-dimensional
sphere.
bell curve.
Ooh, how fancy! That reminds me of the time one of my econ professors. He's like, now if we plot the curve like this, he plots it on there. Now imagine if it was the size of the room, and I'm like, where are we going with this?
Where are we going with
And
this?
imagine we had another axis going this way. And we'd have these curves in these three-dimensional space.
Yes.
For
Keep
this
going.
other unit.
All these undulations in space. Keep going.
Well, that's as far as he went.
Oh.
What? Well, then he was like, now imagine where you'd sit when you have to be on the production possibilities frontier. And I'm like, whoa.
Wow.
This guy
just blew my 19-year-old mind.
I wasn't 19, I was 20.
Oh, my bad.
This was my senior year.
My bad. You're a little old.
I was my senior year. Sitting there just being like, wow.
How long have we been going?
Well, we've been going 18 minutes for this part. We were at 7 before.
Okay. How much longer do we want to go?
Well, at least a half hour.
Oh, okay.
Yeesh. Such a rush all the time. Don't you just, didn't you ever get that, the vibe from Cars 1? Where sometimes you just need to slow down and just enjoy life?
Yeah, I enjoy life by watching House.
That's a waste of society.
I am a waste of society. Yes, we've been over this.
No, I don't. Well, I mean, sure. You want to say that, I suppose.